61%. That's how many U.S. businesses experienced a software supply chain attack in 2023, according to Gartner. This attack surface is constantly expanding. To secure your software supply chain, you first need to control it. JFrog offers an end-to-end platform that manages and controls the binaries and DevOps processes across the entire software development lifecycle. With JFrog, you can deliver trusted software with speed. Visit securityweekly.com/jfrog to learn more and take control of your software supply chain today.
Hi folks, I'm Adrian Sanabria, the host of Enterprise Security Weekly. Every week, we interview the most interesting folks we can find, talking about the most pressing cybersecurity issues and challenges facing the enterprise today. Myself and my co-hosts have each been in the industry for decades, long enough to see the patterns in the industry and explore where trends are going. In addition to enterprise challenges, we also follow the vendor space, the most interesting security startups emerging, technology and product trends, all the most interesting funding and acquisition announcements. Finally, we love to discuss the latest trends in tech and how they'll impact cybersecurity. If you're wondering how the latest in AI, quantum computing, cloud, and DevOps is going to impact security a few years down the road, you should follow the Enterprise Security Weekly podcast.
Welcome back to Application Security Weekly. We just talked with Patty Harrington about IoT devices, how enterprises handle them as a security liability, and how consumers shouldn't have to care. I'm your host, Mike Shima, and I'm here with John Kinsella, and it's time for the news. John, it has been a while since we've had a good, dedicated news segment. So
I know. We still do the news?
We still do the news. There is still insecure software out there. Surprise, surprise. That's not even IoT. I'm going to start off with just a framing article. There's an article from DARPA about translating all C to Rust that they call Tractor. So, hey, thumbs up for having fun acronyms. And they have a call for feedback or sort of a kickoff that's actually happening today, August 26th, as we record this. So I'll follow up from there if there's something interesting. But I want to plant that idea of yes, rewrite stuff in C, blah, blah, blah. But let's use maybe, as you appreciate, let's use a worked example. So my first article here is confusion attacks that were from Orange Tsai looking at the Apache HTTPD. And this is pretty cool because, Apache HTTPD, pretty well known. I think that predates even IoT devices. It's a good venerable system. And a lot of the vulnerabilities here that he found were not necessarily high risk, but they're pointing out that, the architecture of Apache supports something, has a modular architecture that supports a few hundred, I think 200 or 300 modules, about 130 of those are on by default. And there's a lot of parsing nuances back and forth, things that could just kind of go wrong. So you could throw in a question mark and suddenly you have a bypass. You can turn things into an RCE. So really cool, neat, nitpicky types of details that I don't think you could say, one, these aren't memory safety issues, or two, we should just do a line-to-line rewrite of Apache from C into Rust. So my question here, John, is if you look at something like this, what's kind of your reaction from an architecture perspective, a software architecture, and in terms of what to do next? How would you think about Apache?
Start over. And it sounds snarky, but I mean that sincerely. It's right. We see vulnerabilities in HTTPD. I don't know, every year or two. It's a great, it's obviously used by so many people. It's run its life. I think the vast majority of folks out there, particularly as we've become, as the rest of the software stack has matured, my sense from where I stand in the world is more and more folks who are using HTTPD, Apache HTTPD, are using it purely as, that endpoint. How many people are using it for authentication or a lot of things can do? There's a percentage, don't get me wrong. But I think a lot of people are looking to quickly grab that, grab that incoming TCP/80 or whatever you're doing connection, hand it off to something else and let it do what it's doing, unless you're doing static file serving. And either way, I think there's better things out there to do that. So that's step one. Step two, from an architectural point of view, I'm pausing because it's a good question, but I think it's going to be painful, right? Do you want to go back and re-architect Apache, or like somehow make it, more secure? That's a lot of work for something that's established. We've seen other open source projects when they do something like this, right? Let's see, an example coming to mind would be, what is it? There's another open source system out there, not PHP. There's another system out there that they changed the standard, and like a lot of the developers just said they gave up, and they're like, we're not going to go back and do this for the new platform. So it's painful, right? But then going back a step further, talking about bringing Tractor into this, as these type of systems become better and better, I'm still sort of I'm looking for that magic bullet around the previous half with Patty. It's like if we've got a system, I'm going to say there's some AI in there with the rainbow hands that is solid enough that it's able to translate from one language to another, and then the next step is they get good at doing that from a bunch of different languages into something more safe. And I don't care what the more safe is. It might not be a different language. It might be the same language just fixed, sure. Right? At what point do you really care about something like this? Maybe as part of your installation process, think back to like the Gen 2 days, Gen 2 Linux, when you'd actually compile everything on your box. Maybe part of that is going through and fixing all the vulnerabilities because you're running it through a robot, which goes and tracks all the mistakes down. Maybe that's how we do this. I don't know. There has to be a better way. That's sort of my current hope for where we're going.
Yeah, and I appreciated that insight, that feedback, because my thoughts were like, why would we? It's sort of like OpenSSL. People, I think, correctly started to rewrite OpenSSL because that was, I think, a different scenario. But even with that rewrite, they weren't re-implementing the block IO, the kind of the messiness of how the internals work. They were just saying, well, what does TLS need to do? Let's support TLS, and then make a API that can look like it can be a drop-in replacement for that. And I don't know that you can. I don't think you can have that same mental approach or design approach with something like HTTPD. Plus, there are other alternatives already, as you mentioned. So, as much as I'm a fan of rewriting things, maybe we don't. Maybe some things can be just left out to pasture. On that theme, I did come across, so let's look ahead to that idea of WebAssembly. And I think in this year and even last year, I think possibly both of us had that idea of WebAssembly sounds cool, but where is it, or who's using it, or when are they using it? And here is an article from CNCF talking about using WASM Cloud on the factory floor. So we're starting also to get a little bit of theme of IoT here. And they were basically saying WASM, WebAssembly, really easy for their use case because they could write in Rust, for that matter, or they could write in JavaScript. They could write into a language that compiles down to WASM and run these in a Lambda, run these in a tiny virtual machine anywhere that has a very specific use case of some like factory floor type of metrics collection and metrics emission. So the sandboxing already sounds like it's got everything they need. They don't need to open up that sandbox. Other than network access to send off data, you don't need file system. You don't care about starting to break or undo a lot of that default security. So this felt like one of those things that's maybe a narrow use case, but seems like a positive step forward.
Yeah, and to sort of tease out another theme here, again, thinking back about the conversation with Patty and IoT devices, is if there's a platform which people choose to build upon that is secure, I wanted to push back a little bit on the whole idea of thinking about security when you're developing software. That it's never going to happen. But if we can, it'll happen for some of us, but even at scale, no, that's not how we should be fixing this, right? So maybe do we say, hey, if you're developing for IoT or industrial IoT, use WASM, or use WASM with this framework on top of it, whatever the next thing of React for IoT is. And how do we make it not just secure by default, but have these things in such a way that if you say, hey, I need input, or I need to write to a file system, or I need to do whatever, it's there in a secure, hardened, manageable manner. I think WASM has potential for that. I start having jokes in my head like, am I going to be running like WASM in a browser on my thermostat? But maybe, if that's, if you've got enough of a CPU in there and the that makes everything better. Let's just do it.
Feels like the next evolution of the Electron apps are just going to be the WASM machines everywhere. Yeah. And I think one of those aspects too that I agree, we can't just educate and build ourself an awareness into secure design. Everybody knows we make fun of those top 10 lists with kindness, with love, but the idea that we don't have a demonstrable impact from them in terms of secure design. And that's where I wanted to pull in another couple articles here, trying to segue on the theme of secure design, or IoT more so, Black Hat. Here's an article from Listen Up Sonos, over-the-air remote kernel exploits. And this is from NCC Group. They were talking about this at Black Hat, and it felt like, why not pull this in as we're talking about IoT? Two things I wanted to highlight from this. One is it's just a nice write-up. It's a good way of looking at the hardware, finding all the pins, where do you connect to. So if you want to learn about hardware hacking, excellent reference. Start to read about it. But what some of the things it points out is that, especially on this device as an example, there were several security mitigations that were disabled. The KASLR, other stack guards, things like that are just either the developers don't think they're necessary because this is a single-use device. This is like a single-user device, or the device is so underpowered that every single CPU cycle needs to have that processing for really good, sound fidelity, etc. And I guess I can't count, so off by one. The third thing up from this is that, the Wi-Fi module that they're targeting is running within the kernel. And, last week we talked with about CrowdStrike and things that are running in kernels and why that's bad. And, the Linux is also trying to figure out how to secure its environment. So those were three things, since I can count beyond two, that made me think about this article. I'm not sure if you had some other fun with Black Hat or if you got one of these speakers running in your own home.
When we bought this place, there was a bunch of Sonos stuff in it, and I have pulled it out because it was older tech, and I've eBayed off most of it, but at least one I ripped apart to try and get it working. And now I sort of want to go back and play with it a little bit more after seeing this one. I think that's probably one of the themes of today is to use a phrase, actually it's Qualls the CEO used to use it, calling things a sin. I think a sin here is the cost engineering on these devices to use the cheapest possible CPU you can use in them. I don't need you putting a Xeon in the thing, right? That's not going to do the trick either. But spend an additional $5, put a CPU into these devices that can have the extra cycles, either for doing something securely or for encrypting or for doing what's necessary, not tweaking down to exactly what's needed and being proud of yourself. I mean, cool, that's neat from an engineering point of view, but this is an area where horsepower is useful. I don't know, that sort of sticks in my head. There's a lot of great stuff out of Black Hat, and I think we're going to be covering over the next few weeks. I think I have probably one or two more in here. How about I segue over to a really fun one I found? This is from Wired. I'm actually, sorry, it's not Black Hat. It's actually from Usenix. I've linked to the paper in here. I know some of our folks don't have, some of our listeners don't always have accounts or subscriptions to Wired. And this is around something for so Shimano, for folks who don't know, is a big manufacturer of components for bicycles. And probably about 10 years ago now, they started tinkering with the idea of doing wireless components on a bicycle. First road bikes and then mountain bikes. And that would mean your shifters, well, not your brakes, but your shifters, like how you change gears for your derailleur or your back cassette. When you'd click for next gear, up or down, that would send a signal initially over a cable and then over time over wireless back to whichever device. This means you now have multiple batteries you need to charge in your bike and patches to update and all that type of thing. And we're back at this again. I made a joke in our show notes of, we talk about IoT devices and networks in cars. Now you've got them on your bike too. I was really suspicious of this when it first came out. It's oh my God, someone's going to hack that and screw with my gears. I ended up getting a Di2 bike about 5-6 years ago. Love it. But now there's a paper out at Usenix of people actually went, and I think initially this was considered secure from the people who initially sort of poked around it. But now they've figured out, get a hack RF and a few $100s worth of wireless gear. And yeah, you're able to DOS these things. These are using things like Tour de France. So in a situation like that, if someone's able to, even just get someone to miss a gear once over a 3-week race, that could be the difference between, winning that race or not. So this is a really huge deal. I mean, there's all sorts of people are always trying to figure out ways of doping and anti-doping and all that type of thing. So yeah, this is it. It's a funny haha and an interesting paper to think about. But beside putting any of our lives at risk when we're on a bike, it could also have ramifications from a race point of view. So I thought that was sort of fun.
Yeah, and
in a dark way.
Fun way to illustrate different threat models too. And I never thought we would see the day where you can bike by wire. I thought that was going to be reserved for fighter jets. But you've also got kind of on our IoT and legacy device theme. You've got another article here about security RFID smart cards and about what a couple extra CPU cycles might have been doing that we didn't intend, perhaps.
Yeah. So this is an article. This is a white paper which I believe was being published at Black Hat. So My Fair smart cards. They're originally by I think a Chinese manufacturer. I believe they were purchased by Philips. So they're used in quite a lot of places. When I hear Philips, I think healthcare. I hope I'm wrong, but that's a potential. But what was interesting to me about this one, Mike, is you think of an RFID card. I don't have any around here, but you badge in or badge out, or it's a very sort of simple thing. Or maybe if you're actually using smart card devices, maybe you badge to log into whatever. It could be like a nurse's station, hospital, or any other type of thing. Think back, everyone, fondly to the days of Sun computers when you'd have like your smart card. They're not quite so, how would I say? It's not just a stupid little piece of plastic. There's something in there. And what these researchers figured out is there's actually a hard-coded backdoor password that's encrypted. And they did a bunch of other things beside that in here. This paper is pretty good, sort of iterating through a bunch of different known attacks. But then really the meat was realizing that there was that encrypted nonsense there. And once they're able to decrypt that allows them to easily clone these cards, not one by one, but at scale, which means I'm trying not to say second factor authentication, but a physical authentication factor is now, it's not nearly as secure as you thought it was. So again, it comes back to the idea of something which is probably pretty cheap. I'm guessing they're a few dollars each for those cards. And as a result, they've become very prolific. And now there's a bit of a problem on how you're going to secure those.
Bit of a problem. And the problem goes far back, I think, to at least 2007, they were discovering this. And, kind of tying back to our conversation with Patty, the idea that, one, you've got to now replace these as well. And at scale, that's going to be expensive, but also just a process too, because trying to give cards to employees, distributing them is already just also a logistics nightmare as well. So there's all these knock-on effects I think I want to highlight that just makes security a lot harder than just saying, well, use TLS3, or just update your software. These are easy phrases that AppSec can use that kind of does a little too much hand waving over to do that, we have to go through this series of events that are extremely unfortunate to have a fun reference to a good book.
But again, great paper for folks looking for the meat. There's all sorts of independence. There's all sorts of details about what they're doing and how they're doing it, binary dumps and stuff. So it's a great read if you want to get into that space.
So I've got two other articles I want to squeeze in here before the end. One is Listen to the Whispers about web timing attacks that actually work. This is out of Portswigger. And this was also, again, some conversations that were presentations from Black Hat DEF CON. What's really neat here is that Portswigger, as usual, is just really scrutinizing HTTP and behaviors of systems, and essentially just saying, okay, it's one thing to be able to have a theoretical concept that timing attacks can work, that there are things like, blind SQL injection that we've talked about and demonstrated. It's another to show or demonstrate in lab environments. It's another thing to demonstrate in practice what these look like. And so highlighting this mostly because it's a great write-up. Go check out Portswigger, and because it has some great CTF style examples in labs. So it's a good way to be able to go and learn and see how to use the tool, of course, to find these types of vulnerabilities. But they're very much a design aspect and implementation problem that has nothing to do with memory safety that can still leak useful information to an attacker. And a lot of it, I guess I will say, is rather than spreading an HTTP connection across multiple packets, you can just put a whole bunch of HTTP requests into one big packet to see how the server responds. And that's a great way and a very effective technique of being able to figure out how to more reliably do these types of timing attacks. And so it's playing with those quirks, or I say quirks, or even the benefits of things like HTTP2, HTTP3 even, about what the size, the difference between frames and packets. So that's one thing I wanted to highlight real quick. Not sure if you, John, if you're still playing around with web app hacking these days, or if, timing attacks in web apps actually sounds like it's possible now.
I'm not playing around with it unless I'm really, really bored. But at the same time, I think this is really neat, right? It's the idea. How many times have we had someone say to us, "Hey, we'll come out with a vulnerability or we'll show someone a vulnerability or a weakness in their code, and they'll be like, oh, it's a timing attack. You have to actually be able to get that to work." And we all know that's never going to work, especially in production. So I think this is great from that point of view of the thought process it goes through here of like, okay, well, I've got this thing. I need to try and figure out a use case. I need to walk through it. And like, how do I do that? And how do I minimize the noise so there's a higher chance of success? As you said, yeah, there's always great stuff from Portswigger. This is another great one. Long one, but it's a good one.
Long but good. And it's kind of like the first one we started off with from Orange Tsai. It's the idea that, Apache, still a venerable product out there, but there's still fun things to look at even within the HTTP protocol, even within HTTP 1. John, I would be remiss, I won't pull you into this, if we didn't include something related to AI. So got to sneak this one article in here about Slack AI data exfiltration. And this is kind of interesting because, as with pretty much everything except maybe IoT products so far, all types of products are putting AI onto them for understandable reasons or not. But here, Slack AI is saying here is how you can interact with their AI that will give you answers or respond to queries about what's been going on with public channels. So within your organization, for example. And what the attackers demonstrated is that they could use prompt injection attacks and techniques to get the AI to interact with private channels that the requester, the person interacting with the AI, does not have access to. So this is basically, that's where the data leak comes from. And it's pretty impressive how they pull it off. And so it's one of those things that it is a prompt injection attack, but it's also very much that security boundary, that data handling aspect of AIs that I think is a classic, I'll call that a classic software problem as opposed to a modern LLM type of problem. And I'm not sure where I was going with that yet, so that's why I'm going to have to throw over to John to get some final words on this.
Oh, you just gave me a really great idea. You gave me a really great idea. So on this, the core problem here is like everyone is trying to slap this, excuse me, but stupid AI paintbrush on anything they possibly can to try and get someone to sell or buy their product. And I think that's what happened here, right? When Slack started, they modified their privacy terms, I want to say about 3 months ago.
All right.
Like everyone had a bit of a conniption over that. But this is sort of the other side of it. It's not, so that's your legalese, okay, great. But like, hey, what are they actually doing with it? And I'm busy enough, unfortunately, that I don't think about playing with these type of things. Even though I probably should. I think it's worth my while, or I never a while. But yeah, right. So as these things are becoming more and more common, I was just thinking like one of the ways I'll use them occasionally nowadays is, let's see if I filter out my thoughts here. Someone sends me a long document, either from within the company or outside the company where I'm working, and I'm like, I'm not going to read that. I can throw it in these things, and it summarizes amazingly beautifully. But the thought that just popped in my head when you're saying this is like, what if I wrote a long document knowing that other people go start doing that, and I started putting prompt injections inside that doc? So no one's going to find them because they're not going to read some like 7-8 page jackassery about whatever I'm writing. But like at some point, maybe you could actually have it, expect them to feed into one of these systems, and it actually somehow uses it for exfiltrating data. I suspect someone's playing with that idea. But yeah, these things are Swiss cheese. They're getting better, but it's a long road. Where I am sort of in general on these is I'm going to try to figure out how much of my time do I'll say invest in 2024, 2025 to really learn them. I've looked at the coding them before from the back end, but like even just using them as a tool right now versus do I wait a year or two, let the technology sort of mature a bit and then figure out how to leverage them in whatever I do next in the world. So that's sort of where I'm at on these things. It's like they're interesting, but everything that we see today in AI, it's not going to exist in 3 years.
Yeah, and I think I'm going to echo a lot of that sentiment with the statement of it's not solving the problems I have today yet. It's fun to talk about, it's fun to look at, but in this case, I also wanted to highlight that aspect that this is just pulling data that's restricted isn't unique to the AI. The prompt injection is, and it's really fun how they use that and how they got the AI to populate essentially a variable with a private key into a URL that the attacker created. But here's the long doc that John's going to create that's going to have some second order prompt injection. That will be fun, and that's AI related. But I guess that's just my soapbox about what are we looking at, what do we care about. But John, you give us plenty of good time this is not a long document that we're going to ignore. This is a good news segment that you help us catch up on. That's what I'm trying to say here in my long-winded way as usual. So thank you once again for walking us through the news.
Thank you. And I think I'm going to spend the rest of my day thinking about what prompt injections I'm going to put into an appendix of a future doc.
While John's thinking of that, I want to say thank you to everyone else. Do remember to subscribe, share on the socials, check out the show notes, and speaking of listening to good music on Sonos devices, check out Badge and Gun by Sunglasses Kid. We'll see you next time on Application Security Weekly.